All right, good morning. Let's take a look. Let's begin. We are now going to cover some concepts in object-oriented programming. And so there's this topic of object-oriented programming is kind of broad, covers a lot of stuff. It is something, in my opinion, that Python does really, really, really well. So a lot of languages have some kind of object-oriented programming setup, and they're nice. And I think Python has kind of learned, taken elements from other languages and whatnot. And in my opinion, the way Python handles object-oriented programming is great, and so we will kind of just introduce some of the concepts. This is a really big notebook. We will get through some of it today. We'll get through the rest of it on Friday is the plan, and so let's take a look. Okay, I'm going to go ahead and clear these outputs. It should be available on GitHub, and let's go ahead and take a look. Okay, so the way we'll take a look at object-oriented programming is we will discuss kind of our own programmer-defined types. Okay, and so Python has a bunch of built-in types, like the string and list, different data structures and whatnot. Okay, here we're going to create a new type that we're just going to kind of make up on the fly. And so just to kind of illustrate what we're going to try to do, we are going to create a type called point, and this is going to just represent basically a coordinate in kind of Cartesian space, XY coordinate. And there's several ways we can do this, and you could just store the values separately. You could have a variable for x and a variable for y. You could also store the coordinates in a tuple or a list, some kind of thing that allows for the storage of two things. Or what we're going to do here is we are going to create a new type and represent points as objects. Okay, it might be a little bit overkill for this example, creating a new type. Certainly, there's more things you got to kind of think about, and it's more complicated. But it does offer advantages. Okay, and frequently when you read someone else's code, okay, it is not uncommon to see new types being defined, new classes defined, new methods defined, and whatnot. And certainly, all of your usage with pandas and NumPy, those are all implemented using Python's object-oriented structure. So the things where you have methods, where you write the object name dot the method, and so on and so forth. Those are all, applications of Python's object-oriented system. Okay, but we will kind of work through our example of creating our own. Now, in your day-to-day, you probably will not define a ton of classes on your own. You probably won't define a ton of new classes on your own. Okay, however, you might take an existing class and try to extend it, or you might have to kind of read through someone else's code where they have defined classes, and you want to kind of understand what's happening there. So that's that. Or I don't know, maybe you'll do software engineering, and then in that case you'll have to define a whole bunch of classes and stuff like that. Okay. So anyway, a programmer-defined type we call a class, and we create a class using keyword class. Okay. So keywords are basically reserved words in Python that you cannot use for you can't use it as a variable name or something like that. Okay, But then if you want to create a class called point, you just type class point. Now the convention is that when you define a new class, you capitalize it, okay? That's not a hard rule, so Python will allow you to define classes with a lowercase letter, but the convention is that you write, first letter is capital, okay? So you just write class, the name of the class, and then a colon, and that's really all it takes, okay? So right now my class is actually completely empty. All I've done is I've put in what we call a document string, okay? A doc string, this is triple quotes, and this kind of just acts as a header. Right now it's just there so that we don't get an error, okay? Because if I don't include this, Python's going to say this is incomplete because you have nothing there, right? So normally when you define a class, you would put in like some kind of definition of a method or something. But right now, just to kind of illustrate that we are just creating a class, I'm just going to put in a this doc string, okay? And again, a doc string, this is just kind of a placeholder. And generally, when you as you're defining classes and whatnot, it's a good idea to include document strings so that as you're reading through your own code later on and you're wondering like, what does this class do? It's just a description, okay? It's basically a note to yourself or note to future users what it's supposed to do. So class point, this is going to try to represent a point in two-dimensional space, okay? And then, so once you have that, this creates a class object. So if I say, all right, what is point? Okay, now that I've run class point here, this defines it and it says this is class _main.point, okay? So it's the point class is defined under the basically in the global environment, in this kind of the main environment here, which is _main, and so kind of its full name as far as what we're referencing here is going to be _main.point. Double under is double underscore, and sometimes we just abbreviate it to double under or dunder, okay? Double underscore, because it's underscore underscore main underscore underscore. So it's kind of, you're surrounding the word with two underscores on each side, and so this is known as double underscore or double under or dunder, okay? All right, and so if you want, so once you have this class defined, okay, it basically acts as like a factory, okay? Every time you call it, okay, and you call it by putting parentheses, almost like you're calling a function, okay? And so the way you kind of interact with it is like you're calling a function where you kind of use the function name and you put parentheses, but here you're calling a class, and the visual cue to you is that it starts with a capital letter. Again, that's the convention, okay? So we call capital P point, okay, parentheses, and this will create an instance of a point object, okay? And so now we have a point object created at this memory location, okay? So the return value is a reference to some existing point object, which we assign to a blank, and when you print an instance, it tells you what class it belongs to, and this is basically the memory location where this thing belongs, okay? So it's kind of like, I don't know, in some kind of video game, you design like, I don't know, some kind of thing, and then once you have that prototype designed, you can just produce kind of replicas of it, okay? And that's kind of what this is. So up here, we're defining what that object is, and then when you call it, it's going to produce instances of that object. All right, you can, now that we have an instance of the point object, and it's called blank here, right now there's nothing in there, you can assign attributes, and you can do it on the fly. So I can just do blank.x. This is going to create an attribute within blank called x, and I'm going to give it the value 3.0. Then I'm going to do blank.y. This is going to create a new attribute within within blank called y, and it's going to have the value 4.0. Okay. The way you kind of refer to attributes is basically the object name dot the attribute name. So kind of like when you were trying to refer to like the value pi in the math module, you called math.pi. Similar to that, you can call blank.x, blank.y. And once we've defined or given values to these things, we can retrieve them. You just say, hey, give me that value back, blank.y, and it says, yeah, the value you told me to store in blank.y was 4.0, and so here it is back. Blank.y is 4.0. Okay? You can take that thing, blank.x, and assign it to just a new variable outside, in the kind of global environment, x, okay? And so here's x, it's 3.0. Now, this is just a value outside the global environment, outside in the global environment, just called x 3.0. And if I changed, say, what blank.x is, okay, blank.x, I'm going to change that to 5. The x that's, I just said, hey, give it the value 3 back here, that remains unchanged. This x is not related, is not like a reference to the attribute blank.x. It's just at this thing I said, hey, take the value stored in blank.x and assign it to just some other thing called x over here, and that creates the value 3, and that's it. Okay, it's not being modified or anything when I change it here. Okay, you can use this dot notation as part of any kind of expression, and so remember what we can do is we can take a string with placeholders. So I got parentheses, curly brace, :G, curly brace, and what that means is we have a placeholder, and I've got 2 placeholders in general format. :G is general format, and I can call dot format, and what that will do is it'll take the values over here and plug them into the blanks, okay, into these placeholders. So blank.x, which is 3.0, and blank.x is now 5.0, and blank.y is 4. This is going to get put into there, and so it prints out parentheses 5, 4. All right, and so what we can do is we could create a new function. This is going to be a function called print point, and it will take in some object p, and what it will do is it will extract from p the attribute p.x and the attribute p.y, use that in the format function, and it will print this out. So now that I've got this function called print_point, I can call that. I can call print_point on the object blank, okay? And when I pass that in, blank is going to go in as p, and from that we're going to extract p.x or blank.x and blank.y. So we get the values 5 and 4, right? And so that's what we have there. All right, let me give you your first view quiz answer, which today is the letter C. Okay, all right, so let's keep going, and we're going to now define another class, and this is going to represent a rectangle, okay? And so how do you want to represent a rectangle? There's a few ways to do this. What we're going to do is we are going to specify one corner, and then we're going to specify the width and the length, okay? So basically, we want to define a rectangle. We're going to say, here is the corner, here is the width attribute, here is the, what am I going to call it, height attribute, and this is going to define the rectangle. And we can kind of define any rectangle on the Euclidean plane in this form by defining the width, the height, and the corner. Okay. So here again, I'm going to just define a new class called class rectangle. And right now, as far as my class definitions go, I have nothing other than a docstring. Okay. So we're going to just say a class rectangle, and right now we don't have anything there. And so let's go ahead and create a rectangle here. Okay. So I'm going to create an instance of the rectangle called box. So I'm going to make a call to the rectangle class. This will create an instance called box. I'm going to just create new attributes on the fly. We're going to call box.width is 100, box.height is 200, and then the corner of the box is going to be a point class object. All right, and that will and now that I have the point defined, I'm going to define the x and y attributes of box.corner, and it will be placed at the origin. Okay. All right. Does that feel okay as far as defining creating a new instance, and then even within that instance, you can use other class definitions as attributes or things within there. Okay. All right. So here, let's say we've created this thing. So this box as it is, it's centered at 0, width of 100, height of 200. Okay. I'm sorry, and its corner is going to be at 0, 0. So let's say we want to have a function that's going to figure out what the center is right there. Okay. So the way it's going to do that is it's going to take in some instance, okay, and what it's going to return is it's going to return a point with the coordinates of the center there, okay. And so what we want to do is we're going to take the corner of the rectangle right here, which is currently 0, 0, and we're going to add half of the width, okay, and then half of the height. Half the width to the x-coordinate, so that would be 50, and then half the height, so this would be 5100 right there, okay? And then we will return that point that we defined. Okay, so here's my box. My box is just an object there. The box.corner is an object there. All we're doing is we're just saying, okay, you have an instance of a rectangle object at this memory location. You have an instance of a point at this memory location. Right now we have no idea what's going on here. But we can say, hey, what was the corner? What's the x location of that thing? Right now it's at point 0. Okay. I can say, hey, give me the center. Find the center of the box. Okay. And so center is going to be defined by this thing. It's going to return a point. So if I ask, what is center? What is this going to return? When I print out center, what will it look like? It'll look like just this, right? Double under main point, okay, at some other memory location. It's a different object, okay? So we have a double under main point, and the memory location is 288.1a 292.030 versus 291280, okay? If I can call print point, and we will pass the center. So print point, remember, is way back here. We're just going to take the x and the y from that thing and print it out as a coordinate. So I could say, hey, print that point center, and it prints out 5100, which is what we expect, right? And if I call print point on box.corner, okay, that corner is at 0, 0. Okay, objects are mutable, okay? So you can change the state of any object by just kind of assigning, by making an assignment to one of its attributes. So here right now the box width is 100, and I can say, hey, you know what? I want my box width to be bigger. I want my box width to be 150. I want my box height to be taller. From 200, let's add 100 to it, okay? So now my box width is now 150, okay? And if you wanted to do something like that with a function, you can do that. Here we're going to just say, hey, grow the rectangle, okay? grow rectangle is going to take in a rectangle object. It's going to take in two numbers, basically your delta width and your delta height, how much you're going to add to the width and how much you're going to add to the height. And basically, we're going to just update the attribute rectangle.width. We're going to do a plus equals. We're going to just take the current existing width and add delta width to it and store it back into rectangle.width. Rectangle.height, we do the same kind of thing. So this will be our function grow rectangle. I could just say, hey, what are the current values of box width and box height? Right now it's 150 and 300. And I could say, hey, take that box, grow it even more, okay? Grow it by 50 and 100, so it'll go up to 200, 400, right? And I could say, hey, what is box width? And now it's 200 and 400. Okay. So, you know, when we run this function grow rectangle, the argument, this argument rectangle becomes, at least when we run it, becomes an alias for box. Okay. So when we do rectangle.width, we're pulling box width, which at this moment was 150, and then we're adding 50 to it, so it returns back 200. Now, you have to be kind of careful, because if you forget what your functions do, you're not getting any kind of confirmation back that anything happened, okay? So, like if I just click this play button here, okay? Execute the current cell, okay? And I click it, and let's say I click it again, and let's say I click it again, all right? I'm not getting any kind of confirmation that anything is happening here, okay? However, what is going to be the value of box.width and box.height now? It's going to be a lot bigger because I've run this cell several times, okay? So now it's at 400, 800, okay? And if you're not careful about it and you're not kind of keeping track, and I know we frequently just kind of go through the cells and we run things again and again, and then later on, you're doing some computations, and now your box width is at 450, 900. That might be surprising to you, okay? Because it's you're not getting any kind of printout that's saying, hey, this is what happened. So actually, let me go back and rerun some of these things. No, we don't want to. Here, let me just run that. Okay, 200, 400, that's what we want. Okay. So here, yeah, it says the fact that objects are mutable can sometimes make the code difficult to read, especially when you have functions that modify the objects without kind of reporting or printing anything to the screen. So I just kind of demonstrated that to you. And what you can use is you can use the copy module to make kind of duplicates of the object. All right, so here I'm going to do P1 as an instance of the point, and we're going to just give it attributes X and Y, 3 and 4. P1 is going to have X and Y. We're going to create a copy here, and then I'm going to do copy P1, okay? So I've imported copy, and then so to create a copy of it, we're going to do P2 is going to be copy.copy P1, all right? So I can say print point P1, print point P2, 3 and 4, 3 and 4. Are these two things equal to each other? They are not, okay? Because these are, if you can ask the is, so even though they have the same data, this is a 0.34 and this is a 0.34, if you ask what is P1, it is an instance of the point object at this memory location, and P2 is an instance of the point object at this memory location, right? It's kind of just like having two people named John Smith, right? You have John Smith over here, and you have John Smith over here, okay? They are, even though they have the same name, or okay, like the same first name and the same last name, they are two separate individuals. They are not the same. They are not the same, okay? Even if you, and then if you have like a cloning machine, okay? So, I don't know, this is even weirder to think about, but you know, like if somebody steps into the cloning machine, the two clones are now separate individuals, right? So you have these sci-fi movies where somebody steps into the cloning machine and then now the other person's trying to take over the other person's life or whatever, and even though they look the same, they are not the same instance and individual. They are copies of each other. Okay, we have shallow copies and deep copies. Okay, and I showed an instance of this example of shallow copies and deep copies a while back, but it does play a role, especially with kind of objects and things like that. So here's my box width and box height right now. It's 200 and 400. The corner is at this. Remember, within box, the corner is a point object. Okay, it's a point object with a coordinate 0, 0. So if I do box.corner, it's that object 0, 0. Okay, so if I create a copy of the box, okay, and I'm going to create box 2 and box 1 are not the same, okay? However, okay, the corner of box 2 and the corner of box 1, or a box, are the same, okay? So, I don't know. I guess in the science fiction movie, if the person steps into the cloning machine, but let's say they were married to someone, okay, and then they step through the cloning machine. Now you have two instances of the individual, and they are two separate individuals, okay. But you ask, who's your wife, and they're going to say, this is my spouse, this person, and then they're both going to claim the same individual as being their spouse, because until they stepped into the cloning machine, they were one person, and then now this is like some silly plot. Okay, but anyway, right now the corner, box.corner, is referencing the same object here. Okay, so that is what we call a shallow copy. Okay, if you ask, hey, what is the corner? If you look at the address location, 28A19E3E 2A0 is the last. E2A0 is the last. Box.corners, whoops. Address location is also the exact same thing, E2A0. Same address location, meaning it's the same object. If you took box corner and you just changed it, okay, it's going to affect both, right? So if I change box corner to 1 over here, box 1 and box 2's corner is .x, because it's the same thing, okay? Now, if you didn't like that, okay, okay, so here, but however, the attributes, those are separate. Okay, so box.height is 400 and box2.height is 400. But here I'm going to just change the height to 200 on box. So box height is 200, but box 2's height remains at 400. Okay, if you want the objects themselves, you have to do something called a deep copy, right? So if you wanted to kind of resolve this thing where the person steps in the cloning machine and now there's two individuals, and if you don't want them to have this conflict where they're saying, I'm married to the same person, okay, then you have to clone the spouse too, right? So you have to put the spouse through so now, now you'll have, I don't know, all right, so, okay, so let's say Adam steps through the cloning machine, and so now you have Adam 1 and Adam 2, okay, and then you have, and they're both claiming, I don't know, Eve, all right, that's going to cause a conflict. So if you want to avoid this, you have to have Eve step through the cloning machine too, and then you'll have Eve 1 and Eve 2, and you can, Adam, and so that will kind of work out, right? So you can do deep copy. So box 3 is not box, okay, so we can do a deep copy of box. Box 3 and box are different. And then the corner of box 3 will also be different, and you'll have, so that's what a deep copy is. Deep copy, not just clones or copies of the object itself, but any objects that are referenced inside will also get kind of copied and cloned there. So you don't have this these conflicts. All right, let me give you your second answer. Your second answer today is the letter B. B as in bear. All right, so to kind of illustrate some stuff, we want to have these, we're going to create functions that are going to interact with our objects and classes. Eventually, we're going to create methods and things like that. But for now, we're going to create a new class, and class is going to be called time, okay? And it's going to represent the hour, minute, and second. And again, right now, my class definitions are all currently empty, just have doc strings in them, okay? Don't worry, we will get to having proper class definitions. Just for now, we're not there yet, okay? So here I'm going to create an instance of the time object, and within that, and this will be lowercase time, this is an instance of the time object, and we're going to give it hour, minute, second, so we're going to say 11:59 and 30 seconds. So this is the time you get your homework in, and it's not late, okay? And if we want to print it out, we can print it out, and this :0 greater than 2D is going to print out 2 digits, and it will put in a leading 0. So if I call this here, we'll get 11:59:30. I think if I do like 5 seconds here, this 0 greater than 2 will, it'll print out the 5. Whereas if I just if I didn't have that, I think that doesn't look quite right. Yeah. So that's what this does. Okay. So anyway, let's go back to 11:59 and 30 seconds, and that's what we have. So this is our time. Okay. Just to kind of just talk about the way you can think about functions. Okay. You can think about functions as either being pure functions or modifiers, okay? Now, technically, there's nothing preventing a function from being both, or I guess not a pure function, but being a function that returns an object and modifies, but then that it can get confusing, okay? So a pure function doesn't modify. The idea of a pure function is that it doesn't modify any of the objects passed in as arguments. So, you have a function. When you call it, you put in arguments into it. Sometimes you can put in objects as those arguments. And what a pure function does is just kind of takes that information that comes in as arguments, and it returns an entirely new object. Okay, it returns a value, a new object, or something else. Doesn't modify any of this stuff coming in. That is a pure function. Okay, whereas a modifier takes in the objects, and then it modifies those objects that were passed in. Okay, so things like grow the rectangle takes the rectangle in and grows it. That would be a modifier. Okay, whereas find the center doesn't modify, right? It takes in the rectangle, calculates a new location, and returns that, but it doesn't change anything there. Okay. There's a few, as far as writing, software engineering and writing code and stuff like that, there's a few kind of design philosophies. One is prototype and patch, and that is the idea where you start off with a simple thing, and then you get it working, and then once you get it working, then you say, okay, well, let's complicate it by adding something, and you just kind of keep adding features that way. All right? That is that's not a bad approach, okay? But it can lead to, I don't know, a little bit of spaghetti code, a little bit of inefficient stuff, because you started off simple and you're kind of just tacking on things and growing your project that way. Okay, so not everything feels unified and whatnot, but it you just make it more complicated incrementally. Usually, it's easier to kind of think through it that way. Okay. So anyway, the idea here is we're gonna imagine having these instances of time where we have hours, minutes, and seconds, and we can say, hey, what if I wanted to take two time objects and add them together, right? Let's say, right now it's 9:38, and I wanted to say, hey, what time will it be an hour and 20 minutes from now, okay? And I don't know, that would be what, 10:58 or something like that, right? How do you do something like that? Well, the way you can do it, you can just say, hey, take the 2 hours, time 1.hour, time 2.hour, combine them, and that will give us the sum. Take the minutes, add them together, take the seconds, add them together, and you got sum.hours, sum.minutes, sum.seconds, and return that sum there. Okay, all right, so let's try this out. So if I got 9:45, and I say, hey, what time is it in an hour and 35 minutes after 9:45? The way we've implemented our code, it's going to say the time will be 10:80, all right? And we go, okay, well, that's not right, okay? Because clocks only have 60 minutes in them. So what we have to do is we have to say, all right, if the number of seconds is over 60, then subtract 60 and add 1 to the minute, okay? And if the number of minutes is over 60, subtract 60 and add 1 to the hours. Okay, so let's try that out. And we can take our time and when we do that. So 9:45 and 1:35, an hour and 35 later, that takes us to 11:20. Okay, so that so far seems okay. Another way we can think about this, okay? Well, here I have another function. This is going to be a modifier. We're going to just take a time object and increment it by some number of seconds, okay? So we'll take our time dot seconds. We are going to take the number of seconds, add it. If it goes over 60, we'll subtract off 60 and add 1 to the minutes. If the minutes goes over 60, we'll subtract off 60 from the minutes and do that. Okay, so let's try that. So if it's 9:45 and I want to increment it by 90 seconds, then we get 9:46 and 30 seconds. So that's correct. Okay, what if I increment it 185 seconds? So that's 3 minutes and 5 seconds. Okay, 9:45. Well, that takes me to 9:47 and 155 seconds. Okay, so this thing of like going over 60 and subtracting off 60, that only works if the number is between like 60 and 120. So we have to do a little bit of additional work. We're gonna have to do some modular division, okay? So I'll take the total number of seconds, all right? So 185 seconds would be 3 minutes and 5 seconds. So we'll div mod seconds by 60. We'll get the number of minutes and things. Okay, we'll take our minutes, whatever number that is. If it's over, if it's over 120, we'll get the number of hours and minutes and so on and so forth. Then we will increment the seconds by seconds, the minutes by minutes, the number of hours by hours. And then we can finally do our check to see if it's over 60 or whatever, and then subtract 60 and add 1, okay? So now we can try this out again. This is all kind of, again, this is the prototype and patch method where we start off, we try something out, we try another test case, see if it works, and then when we run into a problem, we say, okay, this is where I gotta fix it. So here it is, 9:45, let's try incrementing 185 seconds, and it seems like it's working, 9:48 in 5 seconds. Obviously, you can try out a whole bunch of things. Okay, what if we increment it 4,800 seconds? Is that going to work? Okay, 4,800 seconds is an hour and 20 minutes. And an hour and 20 minutes after 9:48 is 11:08. So it seems okay. It seems okay, all right? And these are modifiers in that we took this time object, this instance of the time object, test time, and we incremented it and it modified it, okay? And again, the only kind of clue that it has been modified is that when we called print time, we can see that it was modified, okay? But again, if you just clicked play on this thing and you accidentally ran the same cell multiple times, it's gonna keep modifying. It's gonna keep modifying, okay? Whereas a pure function, where I'm just kind of like taking these 2 times, okay? Even if I keep running them, because it's returning a new object, the original objects aren't going to keep like growing or changing. All right, so prototype and patch is fine, but it can get unnecessarily complicated. So design development is kind of like you try to think about as much as you can, all of the different kind of high-level structures and what has to be done, and you try to implement as much as you can in kind of like in the beginning, right? So you kind of think about everything that you need to do, and you try to at least set it up, or a framework where all of these things can kind of fit together. And maybe you don't have every single aspect figured out, but at least you have this overarching kind of framework or architecture where things can fit together. So one way we can think about this is we could think about all of our times as the number, basically convert everything into the number of seconds from midnight, per se, okay? And then you can just kind of add two things of seconds and then convert them back into times, right? And this is actually kind of how our computer keeps track of time. There is something known as the epoch, and that's like January 1, 1970 at midnight. And then basically everything that's in your computer, when it's reported as a time, is just how many seconds have elapsed since January 1, 1970, okay? And if you add, 1 minute later is, an additional 60 seconds. But anyway, so we're going to take the number, the time object and convert it into the number of seconds. And then we want something to kind of do the inverse of that. If you have the number of seconds, convert it back to the time, okay? So we'll define a new time instance. We'll div mod the seconds and div mod the minutes to kind of get the hour and the minutes. So we'll do that. So here's the kind of the time. So if I do 9:45, so what we can convert it to seconds. 9:45 is 35,100 seconds after midnight. And then if I take 35,100, convert it into a time, and then print that out, then I'll get 9:45 back, okay? So the way I can do this is, now that I have this, I can just kind of take these total number of seconds, okay? I've got time 1 and time 2. We'll take the total number of seconds, add those two together, and then we'll convert that back into convert from the integer back to a time object. So here I've got 9:45. We'll have it run for an hour and 35, and basically I'm going to convert 9:45 into a number of seconds here, time to int, and then duration hour 35 into time to int, and then we're going to add those things together, okay? And then return, and we get back 11:20. Right? So this seems to work, and this certainly is more, I would argue, is more elegant than this solution that we had here, where we added the hours and then we said, okay, did it go over 60 or something like that? It's just that, when you think about time as a human, it's not so easy to think about these things like 35,100. Okay, that's just not how our brains work. And so we always kind of add the hours and then check if it's over 60. But a computer can easily handle things like that. Okay. Ooh, all right. So I want to introduce methods, but we are also running out of time. So we might just have to wait until Friday here. But let me just kind of, we'll get started, and then we'll discuss more. Okay, so methods are functions, but the functions belong to the class. Okay, the functions belong to the class. So a method is a function, but the key difference between just a regular function and a method is that the method is defined inside the class definition. So you're creating a function inside the class definition. That makes it a method. And then when you invoke a method, when you call it, there's a slightly different syntax. Okay? So remember, we defined a class time by doing this, class time, and then we have this function that prints the time. Okay? It takes that. What I want to do here is I want to create a method, and basically all I'm going to do is just basically copy and paste the definition of the print time function into the definition for class time, okay? And now that I have something inside class time, I don't have to include the doc string. It's probably still a good idea to include the document string, but here, all I've done is I've just copied and pasted the definition of print time into the class definition of time, okay? And then to call it, okay, you can call time.printtime_start. Okay, so this is capital T time. You can invoke the full name of the function, okay, by class name dot the method name, okay. But in this case, because start is an instance of the time object, we can also just do start dot print time, okay. So because print time is a method defined inside the time class, start is an instance of the time class object, and so you can just call start dot method name, and that will print it out, right? And because the start time is 9:45, or it has the attributes hour is 9, minute is 45, and seconds is 0, when you call start dot print time, it prints out as 9:45:0. Okay, we'll take a closer look at methods on Friday, and let me give you your last view quiz answer.